Okay. So in the last lab, I just gave you introduction about system software, right? We discussed what is system software and a few examples under this, right? And what is application software, right? And here are the few examples like for system software, that is system software, operating system and device drivers. As you know, whatever device that we plug into the system, to make it run, we need drivers for that, right? Driver is nothing but a program. In turn, you can say it is a software, right? So to make any device work in a system, you need device drivers. Even that can be a system software. And also, I gave you example of compilers, right? Even compiler is also a system software. And when it comes to the application software, we are well versed with this, right? In day-to-day life, we use many applications like web application, or you can say WhatsApp, Facebook, right? Many more. So this is all about application software. So in your syllabus, you need to study about the compilers. Okay, like how compiler compiles the program. As you know, you already have you studied compiler in your lower semester, right? In the first sem of your engineering, right? So may I know what is compiler? Anyone? What is compiler? Anyone can answer this question, right? What is compiler? No one from the class?
It compiles set of instructions all at once.
Compiles instruction all at once. Okay. Compiles in the sense? Yes?
Converts the source program to the machine.
Okay, correct. It translates, or you can say it converts the program, which is, or you can say it converts the instructions that are written in high level language to low level language, or you can say it converts high level language code to the assembly code or machine level language, right? So here the compiler is a special program that processes statements written in a particular programming language, okay, and turns them into machine language, or you can say assembly code. This is a compiler. And as I said, compiler is also a system software, right? So in the syllabus, you got to study how a compiler compiles the program. That means how the compiler converts a program which is written in higher level language to low level machine code. Okay, so let's see what are the different phases. See, you said the compiler compiles the code, right? To compile the code, it passes through many phases. Okay, it has to undergo many phases. We will see what are those phases to convert the given program which is written in high level language to machine level language. Okay, so this is just an overview. You will feed the high level language to the compiler, which will convert it into low level language, or you can say machine code. If it finds any error, if you have not written the program according to the syntax, whatever the language that you're following, either it may be C, C++, Java, or Python, any language you are following, if you have not written it according to the syntax, when you compile the code, you may end up with compilation error. So if it is not written in the according to the syntax, you will end up with errors, right? So that is about the compiler definition. Now we'll see what are the different phases in compiler design. I'll repeat it again. What are the different phases of a compiler design? That means when you compile a program, what are all the steps it undergoes? That we will see here. The first phase of compiler design is lexical analyzer. Okay, first phase. Second phase is syntax analyzer. Third phase, semantic analysis. Fourth, intermediate code generation. Fifth, code optimization. And the last one is code generation. These are the different phases of compiler design. Okay, this is depicted in this flow. So as you can see here, this is the first phase of compiler design, where the high level language is given to the compiler. This whole thing you can say the compiler. Okay, it consists of all these phases. This is the first one. The high level language is fed into the compiler. So the first phase is lexical analyzer. Okay, output of this see, some process will happen in this phase. The output of lexical analyzer is fed into the next phase of the compiler design, that is syntax analyzer. Output of this is given to the semantic analyzer. Okay, and output of this is given as input for the next phase, that is intermediate code, and the next one is code optimizer, and the last one is target code generation. Okay, after output of the last phase of the compiler design is called as assembly code. Okay, whenever we compile a code, it has to go through all these phases, and you're going to study this in your system software as well. Okay, so in your lab syllabus, you got to study these two phases, that is lexical analyzer and syntax analyzer. What is the process that is followed under lexical analyzer phase, and what is the process that is followed in syntax analyzer phase, that we are going to study under this lab program. Okay, I'll repeat it again. The different phases of compiler is lexical analyzer, syntax analyzer, semantic analysis, intermediate code generation, code optimization, and code generation. Okay, and the output of the last phase is assembly code. This is very important question with respect to Viva. Okay, next we'll move on to the first phase of this compiler, that is lexical analyzer. We'll start with the first phase, that is lexical analyzer. Okay, so lexical analyzer is also called as scanner. Okay, the input for this lexical analyzer is high level programming instructions, or the program which is written in a high level language. Okay, so now this lexical analyzer, what does it do? It accepts the program which is written in a high level language as input, and output of this phase is tokens. You have to remember this. We will feed the high level language as input to the lexical analyzer, and it produces tokens as the output. Okay, so now what is a token? Anyone? Yeah, I said high level language is it takes the high level language and it produces tokens, right? You have studied tokens, characters, and all in C language. So what is this tokens? Anyone?
It's the smallest element in the program.
Okay, tokens are the smallest elements of a program, right? Like, what are the different types of tokens that you have come across?
Identifier, keywords.
Yeah, very good. It may be identifier, keywords, strings, operators, right? All together we call it as tokens. Very good. So the output of this lexical analyzer will be tokens. Okay, let's consider an example here. So let me consider C as a high level language. Okay, I have written an expression in C level language like this. So A is equal to B plus C into D and followed by semicolon. Okay, so this is the expression that I have written in C language, and I'll be feeding this as input for lexical analyzer. That is first phase of lexical analyzer, which is the first phase of compiler design, right? When you feed this as input for the lexical analyzer, it has to generate what? What is the output of this lexical analyzer? Yes, it has to generate tokens, right? It has to generate tokens. So this gives the output as this way. So A is what? It is identifier. So this is the token generated for this character A. Okay. Then is equal to, for this token generated is assign. B, even this is also an identifier, plus. Okay. Then C is also identifier. Multiplication symbol is represented as mult, D as ID, semicolon as semi. Okay. So if I feed this instruction to the lexical analyzer, then this is the output of this phase, okay, for this expression. Okay. So what is the duty of compiler, function of compiler? It has to generate machine code, right? So that machine will understand, process it, and give you the result, right? So it has to, when it compiles, it has to go through many process, under which this is one, that is lexical analyzer, which generates the tokens for the given input. Okay. Now there are a few more things you have to remember when it comes to lexical analyzer. That is, when the scanner, also called as lexical analyzer, when it discards the white spaces, okay, it may be tab or new line character, okay, and also it discards comments from the input. Fine. So when it compiles, I mean, when lexical analyzer phase is there, when input is given for this lexical analyzer, what it will discard the white space that is present in the code, high level language code. Okay. And also it discards the comments that are given in the input. Okay. And rest all other characters are considered, and for the same the tokens are generated. Okay. And the next thing is, the tokens that you get it from the scanner will be fed as input to the syntax analyzer, which is the second phase of the compiler. Okay. So do remember, the output of scanner or output of lexical analyzer is called as tokens. Okay. That is fed as input for the next phase of the compiler, that is syntax analyzer. We also called it as syntax analyzer, and we also call it as parser. Okay. Token will be the input for the next phase, that is parser. Fine. So here is the depiction where the source code is given to the lexical analyzer, which is generate for which tokens are generated, and this is given for the syntax analyzer. Okay. It analyzes, which generates the syntax tree, and which in turn given to the code generator, where the code is sorry, one second. I don't know, it got stuck. One minute. And restart it again. Okay. Yeah, here the output of syntax analyzer is given to the code generator, and which generates the code. Okay. So this is a simple depiction of scanner and parser. Now we'll start with lexical analyzer. Okay, what it does, it generates the tokens, right? So it has to undergo some process to generate the tokens. Okay, that can be done with the help of Lex. Okay, lexical analyzer which generates the token. Okay, that it has to undergo some process, and that process is done by Lex. Okay, so let's see what Lex is all about. Okay, Lex is a tool, okay, or you can say it is a program, or you can say it is a generator that generates lexical analyzer. Okay, so it is a program, okay, which helps the lexical analyzer to generate the tokens. Okay, now it will generate the tokens, right? Like the process followed here is it reads the regular expression. See, this part is very important. Do understand this. Lex will read the patterns, or you can say regular expressions. Okay. Then it produces C code for the lexical analyzer that scans for identifier. We'll see it in the diagram, then you will understand it better. Okay. See, actually this is the structure of Lex. But first we will write the Lex program. The extension of Lex is .l, name of the file, followed by dot, and the extension of the file is L. Okay. This program is given or to the Lex compiler. Okay. First we will write the Lex code. Okay. And that will be given as input for the Lex compiler, and it will generate a C code, that is lex.yy.c. See, all these processes are followed to generate the tokens in lexical analyzer. Okay, to generate this tokens, you need you have to write Lex program. Okay, so what is the first step? You have to write a Lex code. Extension of the file is .l. Okay, it is given as input for the Lex compiler. Once it compiles, it will generate C code. Okay, and that is represented as lex.yy.c. Okay, now since it is a C code, again this will be fed as input for the C compiler. Once it compiles, it gives you output as a.out. Okay, so for whatever the output file is generated here, for this we are going to feed the input. Okay, so once input is given for this output file which is generated here, this will generate sequence of tokens. So this is the structure of Lex, or you can say the tokens are generated when you feed input for the compiler. Okay, do you understand till here? Any doubts? Yes?
No, ma'am.
No? Is it clear to everyone? Yes or no? So please respond.
Yes, ma'am. Yes, ma'am.
Okay, then I'll continue with the next slide. Okay, now, see, I said here the first step is you have to write Lex program, right? You have to write Lex program. See, this step you have to remember always. First, write Lex program, which is given as input for the Lex compiler, which always generates C code. Okay, since it is a C code, again it has to be compiled. Okay, with the help of C compiler, and the output of the C compiler for which you're going to give the input stream, that is high level language. Okay, so once it is fed to this output file, it will generate the sequence of tokens. Okay, so now you have to start writing the Lex program. Fine, and you remember we are going to execute this code in Fedora or in Ubuntu. Okay, I'll tell you the steps to be followed, how to execute the code once I complete the explanation of Lex as well as parser. Okay, or you can say Yak. Okay, once I complete the theory part, then I'll go with the execution part. Fine. So now we'll see how to write this Lex program. Fine. So this Lex input file, or the file which you are going to write it should have three sections. Okay. The first one is definitions, second one is rules, and third one is user code or C code. Okay, so you have to remember this. Whenever you write a Lex code, it should consist of three sections. The first one is definitions, second one is rules, and third one is user code or C code. Okay, and do remember this. You see here, each section is separated by this percentage symbol, right? We call this as delimiters. Percentage. First percentage should follow immediately followed by second percentage symbol. So we call this as a delimiter. Each section is separated by these delimiters. Fine. Three sections are definitions, followed by rules, and then followed by user code or